Hi there. Welcome to Cats in the City, by Sith Sense. I'm Johnny.
And I'm Pearl.
Together, we would like to share with you pieces of interesting knowledge that we find.
And that could be useful to you in the future.
Yes, finally, I have solved this puzzle.
Congratulations. It must have been a really tough puzzle. May I know what is it?
Tower of Hanoi. Have you played this game before?
No, I have never heard of this game before. How do you play it?
No, I think you must have heard of this game before, it's just that maybe you don't know its name. According to Wikipedia, it's also known as the problem of Benares Temple, or Tower of Brahma, or Lucas Tower, or simply as pyramid puzzle.
A pyramid puzzle? Maybe if you describe the game, I might have known the game.
Basically, it has 3 rods and a number of discs with a hole in the center. The disc can slide onto any rod, and each disc has different diameter. For example, let's say, there are 3 discs, and we name the rod as A, B, and C. The game begins with all the discs stacked on rod A, in order of decreasing size, with the smallest disc on top. The goal is to move all the discs from A to C.
I think I know this game. The rule is that you can only move one disc at a time, right?
Yes, you're right. To be more specific, you can only move the uppermost disc to a different tower, and the last rule is that no disc can be placed on top of a disc that's smaller than it.
Simple rules, but there must be a catch.
Yes, as expected, the game becomes more complicated when the number of discs increases. Let's solve the puzzle using 3 discs. Can you show our audience how it is done?
Easy. First, move the yellow disc to tower C, then move the blue disc to tower B, then move the yellow disc to B. These are all legal moves because we've only moved one disc at a time and every disc is smaller than the disc below it. Finally, move the green disc to tower C, then move the yellow disc to tower A. This is getting exciting. Move the blue disc to C, and lastly, move the yellow disc to tower C, and the puzzle is solved.
Now, I'm going to challenge you to a 4 discs puzzle, and then 5 discs, and then 6 discs, and then...
Wow, wait, now that I remember this game, I also remember that it's quite challenging to solve 4 discs, let alone 5, 6, or more discs.
It's actually quite easy when you know the trick to solve it.
Oh, really? Please enlighten me.
The trick is actually to reduce the puzzle to a state that we already knew how to solve. This strategy is known as the reductionism or the reductionist approach.
Reductionism is a problem-solving method that involves breaking down a complex problem into smaller, more manageable parts or simpler problems. By reducing a problem to its fundamental components or finding analogous situations that have been previously solved, we can apply existing knowledge, techniques, or solutions to tackle the problem at hand.
Correct. Let's go back to your 3 discs puzzle. We can actually reduce the number of discs to 2 discs. The origin is Tower A, but we change our destination to Tower B, meaning that instead of moving both of the discs to Tower C, we move them to Tower B.
I see, moving 2 discs is so much easier, and I just have to move the destination to Tower B. Then, I can easily move the biggest disc to Tower C, which is empty.
Yes, you've got it right, and after that, the puzzle becomes moving 2 discs from Tower B to Tower C. In conclusion, our reductionist approach only requires 3 steps to solve this puzzle.
Okay, let me see if I get this right. Firstly, we reduce the number of discs to 2 discs, and change the destination to Tower B. Secondly, we moved the biggest disc to Tower C, which is empty, and finally, we move the 2 discs from Tower B to Tower C.
In the third and final step, it's actually a new puzzle with 2 discs, moving from Tower B to Tower C. The origin has changed from Tower A to Tower B. Moreover, we can further reduce this new puzzle into another puzzle of 1 disc, with the origin at Tower B and the destination at Tower A, but we don't really need this reduction step because a puzzle with 2 discs is very simple to solve.
Let me recap the whole process. For a 3 discs puzzle, we reduce it to 2 discs puzzle, change the destination of the 2 discs to Tower B, move the biggest disc to Tower C, change the origin of the puzzle to Tower B where we have the 2 discs, and move the 2 discs to Tower C.
Yes, you are correct.
Similarly, for a 4 discs puzzle, we reduce it to a 3 discs puzzle, change the destination of the 3 discs to Tower B, move the biggest disc to Tower C, change the origin of the puzzle to Tower B where we have the 3 discs, and move the 3 discs to Tower C.
Yes, you are correct again.
Using the same strategy, we can solve for puzzle with 5 discs, 6 discs, and much more. This is genius.
And did you notice that we keep repeating the 3 steps in our reductionist approach?
This is a recursion. OMG! We can write a Python code to solve the Tower of Hanoi puzzle.
Yes, you are absolutely right. And the code is actually very simple. I bet you can finish writing the code in less than a minute.
Okay, I'll give it a try. Let's define our function as Hanoi, with 4 parameters, n for number of disks in the puzzle, o for origin tower, h for helper tower, and d for destination tower.
This is a good start.
The first step is to reduce the number of disks by 1, the helper tower becomes the destination tower, and vice versa, the destination tower becomes the helper tower. Next, we'll print the instruction to move the biggest disk from origin tower to destination tower. The third and final step is to move the remaining disks from the new origin tower to the final destination tower. The helper tower has become the new origin tower. That's it. Wow, the code is really very simple.
Don't get too excited yet. See here, when you run your code, you'll get a recursion error. The maximum recursion depth has been exceeded. I have made the same mistake too. Do you know what's the mistake in your code?
I see. Here, I forgot to include the base case.
Yes, remember that every recursive function must have a base case. Without a base case, our function will keep calling itself until we reach the maximum recursion depth.
In our case, the base case for our recursive Hanoi function is n equals 0. When n equals 0, our Hanoi function will stop because it has successfully solved the puzzle.
Rationally, n cannot be negative, so to write our code more naturally, we can use an if statement to run our code, if n is greater than 0.
Our code prints out the step-by-step moves on how to solve the Tower of Hanoi puzzle with 3 disks.
Congratulations! Let's test your code with a puzzle of 5 disks, shall we?
It's a piece of cake. Our code solved the puzzle almost instantly. The solution is quite long. Our audience can try to follow the solution, step by step, to see if it's correct, but I'm confident it's the correct solution.
That's all from us this time. I'm Johnny.
And I'm Pearl.
Bringing you bits and pieces of interesting knowledge from cats in the city.
Thanks and see you next time.